Preparing for Elastic SRE interview questions and answers interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you define the role of an SRE at Elastic? An SRE at Elastic applies software engineering to reliability, rather than treating operations as manual support. I would focus on defining meaningful SLOs, automating repetitive work, improving observability, and responding effectively to incidents across distributed services. For Elasticsearch-based systems, reliability also means protecting data durability, query performance, and cluster recovery. I would balance feature delivery against error budgets, use incidents as learning opportunities, and continuously reduce operational toil through better tooling and system design. While answering, focus on SRE principles, customer reliability, automation, measurable service levels, operational ownership, and how Elastic's distributed search and observability products create unique reliability challenges. Question 2. How would you design SLOs for an Elastic Cloud service? I would begin with customer journeys, such as indexing documents, executing searches, and retrieving data. For each journey, I would define SLIs covering success rate, latency percentiles, and, where appropriate, durability or freshness. I would separate data plane availability from control plane operations like deployment changes. Targets must reflect customer expectations and realistic architecture, not arbitrary perfection. The resulting error budget would guide release velocity, operational priorities, and decisions to pause risky changes. Make sure to cover customer-facing indicators, availability, latency, durability, correctness, percentile measurements, realistic targets, error budgets, and the importance of separating control plane from data plane behavior. Question 3. An Elasticsearch cluster suddenly shows high search latency. How would you investigate? I would first confirm whether the issue affects one tenant, index, region, or the entire service, then compare current latency percentiles with the baseline. I would inspect CPU, memory, JVM pressure, garbage collection, disk I/O, thread pools, rejected tasks, shard allocation, and slow logs. Next, I would correlate the timing with deployments, traffic changes, mappings, or query patterns. I would mitigate safely, perhaps throttling expensive work, while preserving evidence and communicating status to stakeholders. In your answer, talk about confirming scope, checking latency percentiles, resource saturation, slow logs, shard distribution, query changes, JVM pressure, garbage collection, recent deployments, and safe mitigation before root cause analysis. Question 4. What causes Elasticsearch cluster instability, and how would you prevent it? Cluster instability usually comes from resource saturation or poor data distribution. Common causes include excessive shard counts, oversized shards, uneven allocation, sustained JVM pressure, disk watermarks, overloaded master-eligible nodes, and sudden indexing or query spikes. I would prevent it with capacity models, shard sizing standards, dedicated roles where justified, resource limits, admission control, and alerts based on leading indicators. Regular testing of scaling and recovery paths would complement those controls. Be sure to mention memory pressure, oversized shards, uneven allocation, excessive shard counts, disk watermarks, master instability, workload spikes, capacity planning, admission controls, and proactive monitoring. Question 5. How would you choose an appropriate shard strategy for a new Elasticsearch workload? I would start with projected data volume, retention, ingestion rate, query concurrency, and expected growth. Shards should be large enough to avoid unnecessary overhead but small enough to recover and distribute efficiently. The right value depends on workload and hardware, not a universal rule. I would consider rollover for time series data, replica requirements, and future expansion. Then I would validate the design with representative load tests and monitor recovery behavior after failures. Focus on data volume, growth, query patterns, shard size, ingestion rate, retention, concurrency, recovery time, node capacity, rollover policies, and avoiding both undersharding and excessive shard overhead. Question 6. What is an error budget, and how would you use it at Elastic? An error budget is the amount of unreliability permitted by an SLO over a defined period. If availability is targeted at 99.9%, the remaining fraction represents the budget for failures, latency violations, or other agreed indicators. I would use burn rate alerts to identify rapid consumption and use the remaining budget to inform release risk. When the budget is exhausted, the team should prioritize reliability work, reduce change risk, and restore customer confidence. While answering, explain the relationship between SLOs and permitted unreliability, release decisions, risk management, stakeholder alignment, and why error budgets should drive behavior rather than become passive reporting metrics. Question 7. Describe your approach to responding to a major production incident. My first priority is establishing impact, severity, and an incident commander. I would assign separate owners for investigation, mitigation, communications, and documentation, then stabilize the system using the safest reversible action available. Updates should be factual, time-bound, and customer-focused. After recovery, I would verify service health and data integrity rather than assuming the alert cleared. Finally, I would lead a blameless review that produces specific, owned actions and tracks them to completion. Make sure to cover detection, incident command, customer impact, mitigation, clear communication, role separation, decision logging, escalation, recovery validation, and a blameless post-incident review. Question 8. How would you investigate high JVM memory pressure in Elasticsearch? I would examine heap utilization over time, garbage collection pauses, allocation failures, circuit breaker events, query logs, aggregations, field data usage, shard counts, and recent workload changes. High pressure may reflect expensive queries, poor mappings, excessive shards, or insufficient capacity. I would first protect availability by reducing abusive workload or routing traffic safely. Longer term, I would optimize mappings and queries, improve data lifecycle policies, resize resources, and add alerts before pressure becomes an outage. In your answer, talk about heap trends, garbage collection, field data, query behavior, aggregations, circuit breakers, shard count, caches, workload changes, temporary mitigation, and longer-term capacity or design fixes. Question 9. What is the difference between a primary shard and a replica shard? A primary shard owns the authoritative copy for a portion of an index and coordinates writes for that shard. Replica shards duplicate primary data, provide redundancy, and conserve searches, although they do not independently replace a disaster recovery strategy. Elasticsearch distributes these copies across nodes to reduce correlated failure risk. Replicas improve availability and sometimes read capacity, while snapshots provide recoverable historical state if data is deleted, corrupted, or lost across the cluster. Be sure to mention data distribution, write ownership, read scaling, fault tolerance, replication behavior, allocation awareness, recovery implications, and why replicas do not replace snapshots for disaster recovery. Question 10. How would you perform a safe rolling upgrade of an Elasticsearch cluster? I would review compatibility requirements, client versions, release notes, known risks, and rollback constraints before changing production. I would validate snapshots, test the upgrade on a representative environment, and confirm sufficient capacity and healthy replicas. During the rolling process, I would drain one node at a time, verify cluster health and recovery, upgrade it, and observe key metrics before proceeding. I would use a canary or staged rollout with explicit abort criteria and communication checkpoints. Focus on compatibility, backups, version sequencing, shard allocation, cluster health, node draining, quorum, client behavior, rollback limitations, canary validation, and monitoring throughout the upgrade. Question 11. How would you design disaster recovery for an Elastic deployment? I would begin by defining recovery point and recovery time objectives with the customer and product teams. Snapshots should be automated, encrypted, retained appropriately, and stored independently of the production cluster, ideally with cross-region protection. For stricter objectives, I would evaluate cross-cluster replication or another architecture. The plan must include credentials, network dependencies, capacity, runbooks, and ownership. Most importantly, I would perform scheduled restore tests and measure actual recovery time and data completeness. In your answer, cover RPO, RTO, snapshots, repository durability, cross-region copies, restore testing, replication options, dependency mapping, security, runbooks, and validation of both availability and data correctness. Question 12. What monitoring and alerting would you implement for Elasticsearch? I would monitor both customer-facing outcomes and internal leading indicators. Core signals include request success and latency percentiles, indexing throughput, rejected tasks, JVM pressure, garbage collection, CPU, disk watermarks, file system latency, shard allocation, recovery progress, and master stability. Alerts should be tied to action, use sustained thresholds or burn rates, and avoid paging on harmless variation. Dashboards would provide regional, tenant, and cluster views so responders can quickly distinguish symptoms from causes. Make sure to cover customer symptoms first: saturation signals, JVM and disk health, indexing and search performance, rejected tasks, allocation failures, alert quality, dashboards, burn rates, and actionable thresholds. Question 13. How would you reduce operational toil on an Elastic SRE team? I would measure recurring operational tasks by frequency, time, risk, and customer impact, then prioritize the largest sources of repetitive work. Examples include automated deployment validation, shard allocation workflows, capacity checks, certificate rotation, and standardized incident diagnostics. I would build guardrails, dry runs, permissions, and audit trails into self-service tools rather than simply adding scripts. After rollout, I would measure time saved, failure rates, and engineer satisfaction to confirm the automation genuinely improves reliability. While answering, define toil as repetitive, automatable operational work and discuss measurement, prioritization, self-service tooling, safe automation, documentation, ownership, and confirming that automation reduces incidents rather than hiding them. Question 14. How would you troubleshoot a sudden increase in indexing rejections? I would identify the rejection type and affected nodes, then inspect indexing thread pools, queue depth, CPU, disk latency, JVM pressure, shard allocation, and ingestion rate. I would compare the timing with traffic or schema changes and check whether bulk requests became larger or more concurrent. Mitigation might involve controlling producers, reducing non-essential work, or adding capacity. I would ensure clients use bounded exponential backoff, because uncontrolled retries can amplify saturation and prolong the incident. Be sure to mention bulk behavior, thread pools, CPU and disk saturation, refresh settings, mapping explosions, shard distribution, backpressure, client retries, queue limits, and avoiding retry storms. Question 15. How would you manage capacity planning for Elastic Cloud clusters? I would model capacity from ingestion volume, document size, retention, replica count, query concurrency, aggregation complexity, and expected growth. Storage alone is insufficient. CPU, heap, disk I/O, network bandwidth, and recovery capacity can become the limiting factors. I would maintain headroom for traffic spikes and node failures, forecast using observed trends, and validate assumptions with load tests. Capacity decisions should balance reliability and cost, with clear scaling triggers and ownership. Focus on workload forecasting, storage growth, retention, CPU, memory, disk I/O, query and indexing mix, headroom, failure scenarios, scaling lead time, cost, and load test validation. Question 16. What is your approach to safe automation in production operations? Safe automation should be idempotent, observable, permissioned narrowly, and designed around explicit failure modes. I would validate inputs, support dry runs, limit concurrency, record every action, and use progressive execution rather than changing an entire fleet immediately. High-risk operations should require approval or strong policy checks. The automation needs tested rollback or recovery procedures, although rollback may be impossible for destructive data changes. I would rehearse failures and monitor outcomes after deployment. In your answer, discuss ID impotency, validation, least privilege, dry runs, progressive rollout, rate limits, auditability, rollback, human approval for high-risk actions, and testing failure scenarios. Question 17. How would you investigate a suspected data loss incident in Elasticsearch? I would first distinguish true deletion from query, permissions, alias, refresh, or allocation problems by comparing APIs, replicas, snapshots, and application records. I would preserve logs and reconstruct the timeline from audit events, deployments, lifecycle policies, and user actions. Next, I would quantify affected indices, tenants, and time ranges, then stop further destructive activity if safe. Recovery would use the least disruptive verified source, followed by integrity checks and transparent customer communication. Make sure to cover scope confirmation, source of truth analysis, audit trails, deletions versus visibility issues, replication, snapshots, retention, permissions, timeline reconstruction, preservation of evidence, and customer communication. Question 18. How would you handle a noisy alert that pages engineers repeatedly without useful action? I would review the alert's intended action, historical firing pattern, customer correlation, and responder feedback. If it does not require immediate human action, it belongs in a dashboard or ticket rather than paging. I would improve the signal using sustained thresholds, burn rates, grouping, dependency awareness, and maintenance suppression. Every page should identify impact, likely context, and a runbook. After tuning, I would track page volume, acknowledgement time, and missed incidents to avoid overcorrection. While answering, focus on alert purpose, customer impact, actionable thresholds, deduplication, severity, ownership, suppression during maintenance, feedback from responders, and measuring page quality after changes. Question 19. Tell me about a time you disagreed with an engineering team about reliability risk. In that situation, I would avoid framing reliability as a veto. I would quantify the risk using historical incidents, slow impact, blast radius, and rollback complexity, then explain the trade-off in business terms. I would propose mitigations such as a canary, feature flag, rate limit, or staged rollout rather than simply rejecting the release. If disagreement remained, I would document the decision and escalation path. Afterwards, I would review outcomes and improve the decision framework. Be sure to mention a specific situation, evidence-based risk assessment, shared goals, trade-off discussion, proposed mitigations, respectful escalation, decision ownership, and what you learned from the outcome. Question 20. How would you improve reliability when launching a new Elastic observability feature? I would involve SRE during design, not after launch, and document dependencies, failure modes, capacity assumptions, and customer critical paths. Before release, I would define SLIs and SLOs, test realistic ingestion and query loads, exercise dependency failures, and verify dashboards and runbooks. A staged rollout with feature flags, canaries, and clear rollback criteria would limit blast radius. After launch, I would watch error budget consumption and conduct a review to capture reliability improvements. In your answer, cover reliability requirements, dependency mapping, SLOs, load testing, failure injection, staged rollout, telemetry, capacity, rollback, customer impact, and post-launch review. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.